Good evening, sir.
Good evening, Yukta. Okay, Yukta, just wait for a few minutes, then we'll be starting.
Okay, sir.
So in the last class, we did physics, right?
Yes, sir.
Okay, today we'll do chemistry.
Okay, sir.
So out of the 3 classes, one day we'll be doing physics, one day chemistry, and one day bio.
Okay, sir. So the next class we'll do bio, right?
Yeah, the next class will be bio.
Okay, sir.
Just wait till everyone joins.
Good evening, sir.
Yeah, good evening, Jitendra. Good evening. Just wait few minutes. So today we'll do assignment from the chapter, the two chapters which are coming. The assignment from chapter is matter around us pure, and one more chapter is there, I think, that we can do. Just wait.
Good evening, sir.
Yeah, good evening, Sharwan. Okay, I think everyone is ready now. Now we can start with the assignment. Okay, is there what is your syllabus, possible syllabus that's coming in your exams?
So for me, they didn't give the syllabus for the exam yet.
Okay, so no, in your schools,
Final
which part
exam,
are being
sir.
covered? Which part is being covered?
So, sir, in chemistry, we are doing the third chapter, atoms and molecules.
Okay, atoms and molecules has been started.
Yes, sir. We are done with
Okay.
half of the chapter.
Okay. So, for other people, what about other people? Yes, is there any update on your syllabus?
No, sir.
No. Okay. Okay, so let's see. Let's start with the assignment of each matter around us pure. We'll discuss that. And in the next week, we'll continue with this chapter, with the third chapter which we had started, atoms and molecules. So we had started with atoms and molecules. We'll continue that in the next session. Okay, so let's see a quick revision of this chapter. Pure substances. So what are pure substances? A homogeneous material which contains particles of only one kind has a definite set of properties that we call as the pure substance. So you can say that a pure substance has a definite set of properties and it is a homogeneous material which contain particles only of one kind. So it should contain particles only of one kind, then we call it as a pure substance. A mixture, it is a product formed by mixing two or more substances. They may be elements or compounds or both in any proportion. So ratio and proportion is not fixed for a mixture such that the individual substances do not undergo any chemical change but retain their properties. So whatever the properties are there individually, they are retained by them. That means they are still the same. Got it? Then a homogeneous mixture, a mixture in which different constituents are mixed uniformly. So different constituents, they are mixed uniformly. We call it as a homogeneous mixture. A heterogeneous, we had seen various examples of homogeneous mixtures, like a solution of salt in water, a solution of sugar in water. All these are heterogeneous mixtures. So homogeneous mixtures. Heterogeneous mixtures are the mixtures in which different constituents are not mixed uniformly. For example, a mixture of sand and water, mixture of husk and water. Okay. So you can also say a mixture of chalk powder and water. So they are not mixed uniformly. A mixture of oil and water. All these are heterogeneous mixtures. A solution, so when I say solution, so generally means a true solution. Okay. So a homogeneous mixture of two or more substances. If you have a homogeneous mixture of two or more substances, we call them as the solution. Solute is a component of the solution which dissolves in the solvent. Okay. A component of the solution which dissolves in the solvent we call as the solute. Then true solutions. So what are true solutions? Yes. Now, true solutions. A solution in which the particles of the solute break down to such a fine state that they cannot be seen under a powerful microscope, like the solutions of sugar and water. So the particles of sugar, they become so small that they cannot be seen even under a microscope. Okay, that we call as the true solution. Concentration of the solution, it is measured in two ways. The concentration of a solution is measured either as mass by mass or mass by volume method. Okay. So also I will be sending this one with just in your group so that you can have a quick revision of all of them. You can revise them thoroughly, everything. All the definitions are listed here. And after I think all the definitions are clear to us, we can move to the questions. We have saturated and unsaturated solution. So the saturated, as we know that in a saturated solution, no more solute can be dissolved. Okay. Whereas in an unsaturated solution, you can dissolve more amount of solute. Sharwan,
Yes, sir.
does the saturation of a solution depend upon its temperature?
Mm. Yes, sir.
So what happens to the solubility with the increase of temperature?
So it dissolves the maximum amount of solute.
Yes. So with the increase of temperature, solubility increases. Okay. What is a super saturated solution?
A solution at a higher temperature which contains more amount of solute than the required to make a saturated solution.
Yeah, just a simple meaning to understand here, that as the temperature increases, solubility increases. Okay. So what you do, you increase the temperature and you keep on dissolving more and more solid. Okay. So such a solution is called as a supersaturated solution. For example, suppose you want to dissolve sugar in water, and at a given temperature or at room temperature, you can dissolve a very small amount of sugar in. So as the temperature increases, okay. So as we can heat water, so as we boil water, you can add more and more sugar to it. That we call as a supersaturated solution. The last one, Tyndall effect. So Sampath, what is Tyndall effect? Yeah. Sampath, what is Tyndall effect?
Well, Tyndall effect is a phenomena where when a light beam is passed through any solution, if the light is scattered due to the large size of the particle, that scattering of light or that scattering of beam of light is called Tyndall effect.
Okay. See, the scattering of a beam of light when it falls on tiny particles is called as Tyndall effect. And due to this, the path of the light becomes visible. Tyndall effect is shown by suspensions and true solutions, suspensions and colloids, but not by true solutions. Okay. Let's see the questions here. So for the first question, how is the chemical change different from a physical change?
So physical change is a temporary change.
Okay, physical change is a temporary change, and chemical change.
It's a permanent change.
Okay, it is a permanent change. Okay.
So in a chemical change, there's a new substance form, whereas in a physical change, there's no new substance form.
Yeah, this is the main point. You should be adding this as the key point. This should be the first difference between chemical and physical changes, right? So in a physical change, no new substance is formed, whereas in a chemical change, a new substance is formed with entirely new chemical properties. Now from this one, identify the heterogeneous mixture from the following. So which of them is a heterogeneous mixture? Harshit will answer. Harshit, which of them are heterogeneous mixtures?
So
See, you are going air, soda, water, soap solution, brass. So out of them, which of them are heterogeneous mixtures? I hope you know the meaning of heterogeneous.
soda and soda water,
Yeah.
soda water and soap solution.
See, in the heterogeneous mixtures, the particles they do not have a uniform composition. They have a non-uniform composition. So does composition?
Solution.
Yes. Does air have a uniform composition everywhere? No. Air does not have uniform composition everywhere. At some places it may have a high. At some places it may have a low amount of oxygen. At some places the air may contain a lot of dust. At some places it may be very clean. Okay. So air is a heterogeneous mixture. Air is not a homogeneous mixture. Soda water. Okay. So soda water, it is a homogeneous mixture. When soda is mixed with water, it forms a soda solution, and the soda solution you can't find them separately. They are so well mixed with each other. So soda water, it is a homogeneous solution. Okay. Soup. What can we say about the soup solution? Ryan?
Yes, sir.
Yeah, Ryan, what can we say about the soup solution?
Uh-huh. I didn't hear you right. Can you say it again?
What can you say about the soup solution?
It does
Is
not
it
completely mix with water.
no? So is it heterogeneous or homogeneous?
It's heterogeneous.
The soap solution is heterogeneous, not because it is something like that, but uh, it is heterogeneous because the particles of the soap solution, they are visible. They
Okay.
they can be observed under a
So they can
microscope.
also be not, they can also not uniformly mix and
Yes.
not and be heterogeneous,
Yes.
homogeneous.
What about brass?
Brass, it's properly mixed and like the particles do not look separate. It's one same thing. So it is homogeneous.
Okay, brass is a homogeneous mixture. Of which two substances? Which two substances are used for making brass?
Sir, zinc and copper.
Which one?
Zinc and copper.
Yeah, zinc and copper. This is zinc and copper. Okay, now see question number 3. Mention 2 ways to liquefy atmospheric gases. So how can we liquefy atmospheric gases? Is there any method by which we can liquefy the atmospheric gases?
Yes, sir.
Liquefy atmospheric gases means we want to liquefy air. So can we make air as liquid?
Sir, we can't, but we can.
Yes.
Sir, we can make.
Which one?
Sir,
We
with
can make,
pressure.
sir.
See, there are two methods to liquefy the gases. One method is you either increase the pressure. So either you increase the pressure for this third one. First method is you increase pressure. So you increase pressure so much so that the particles of gas, they come very close to each other and they turn into a liquid state. So increase pressure. The second method is you decrease the temperature. So these are the two methods to liquefy the gases, where the method that is generally used is increase of pressure. Then, okay, for question number 4, which one of the two solutions will scatter light? Sugar solution or soap solution?
The soap solution.
So
Why soap solution and why not sugar solution?
So soap solutions are the collider solutions. They
Yeah,
can be
soap
seen.
solution is a colloidal solution, and the particles of soap solution, they are much bigger in size to scatter the light. Okay, so particles of the soap solution, they are bigger in size, so they can scatter the light. Whereas for the sugar solution, the particles of sugar solution are very small to scatter the light. So therefore, Tyndall effect will be observed in sugar solution. Sorry, yeah. Write any one property of suspension. Yukta, can you tell any one property of suspension?
Yes, sir, suspensions are, the particles of suspensions are very small in size, so they are naked twice and they show Tyndall effect. But
They
still,
should?
they show Tyndall effect and they are heterogeneous mixtures.
Yes. So suspensions, the particles are visible in suspensions and they show Tyndall effect. Then next one is for question 8. Identify solute and solvent. Which one will be solute and which one will be solvent? Think everyone and just give me 1 minute. I'm coming in 1 minute after having a glass of water. So just do a question number 8. Think of it. Have you got the answer?
Sir, ethyl alcohol is solute and water is solvent.
Which is solute?
Ethyl alcohol.
Why ethyl alcohol is solute? Yeah, why ethyl alcohol is a solute and water is a solvent? Pranav? Is this Pranav? Pranav? Okay. So Pranav, tell. In question number 8, you have to identify solute and solvent in 80% solution of ethyl alcohol with water. Which one is a solute and which one is a solvent? Okay, see the criteria which we use for deciding which one is a solute and which one is a solvent. We use this criteria here. The criteria used is if you have a solid and liquid, okay, a solution made by a solid and liquid, so then this liquid will be solvent and the solid will be solute. If you have liquid and liquid, have liquid in liquid, or if you have gas in gas. So in such a case, if it is liquid in liquid or if it is a gas in gas, so for such cases, the quantity which is present in greater amount, that is considered as the solvent, whereas the one which is present in a smaller amount is the solute. So here, so in this case, in this question, you have a liquid in liquid. Am I correct? This is this liquid in liquid? See, ethyl alcohol and water,
Yes, sir.
both are liquid.
Yes, sir.
So ethyl alcohol is 80% and water is only 20%. So which one will be considered as a solute? The one which is present in lesser amount. So which one is present in lesser amount?
Sir, water is solvent.
Yeah, water is solute and ethyl alcohol is the solvent. Got it now? Since it is present in a
Yes.
greater amount. So ethyl alcohol is the solvent and water is the solute. Okay, what are the two components of a solution? Just we discuss.
The solute and solvent.
What are the two components of a solution? Yes, what can be the components of a solution?
Solute and solvent.
Solvent.
Yeah, solute and solvent, right? Solute and solvent are the two components of a solution. Then the wool being knitted into a sweater is a physical change. Justify the statement. Okay. So answer this. Why we call it as a physical change? The wool being knitted into a sweater. Jitendra? Jitendra will answer this. Jitendra?
Yes, sir.
Yeah, why it is called as a physical change?
Sir?
Why we call it as a physical change? Pranav? Pranav? It seems all of you have become inactive. Rayan?
Yes,
Yeah, so Rayan, why do we call it this process to be a physical change?
because no change of the chemical composition occurs.
There is no change in the chemical composition. It is just a change of shape. Okay, it's just a change of shape. Whereas in a chemical process, there is a formation of a new substance with different properties. Okay, so even when the sweater is knitted from wool, it is a physical change because its properties are still the properties of wool. So it is a physical change. Sampath, what are pure substances? Yeah, Sampath, what are pure substances? Sampath? Sampath? Anyone? No one is able to answer this? Sharwan?
Sir,
The pure substances are made up of only one kind of particle.
Yeah, pure substances are the substances which can be made of or which are made up of only one kind of a particle. Now the 12th one, name a metal that is liquid at room temperature.
Mercury.
Mercury, okay. Name the technique to separate salt from seawater.
Evaporation.
Sir, evaporation.
Evaporation. Butter from curd.
So
The
centrifugation.
centrifugation.
Centrifugation, okay. When a solution is said to be saturated.
When it reaches the when the solute is reaching its saturation level.
Yeah, or you can say that when no more solute can be added, then we call it to be saturated. Now see, 16th one, classify brass and diamond as element and mixture. So from brass and diamond, which one is an element and which one is a mixture?
So diamond is an element
Diamond is
and brass is a
element and
mixture.
brass is mixture.
Very good. So diamond is an element, whereas
Brass is a mixture.
then you have to separate a mixture of salt and ammonium chloride. Which method will you employ and why?
sir, we can apply the method of sublimation.
Sublimation. Yes, we'll use the method of sublimation as ammonium chloride easily sublimes into gaseous state. Okay, so we'll use here the sublimation method. Classify soap and tin as element or mixture.
So tin is element, soap is mixture.
Yeah, tin is element, soap is a mixture. Okay. On which factor does a solution on which factor does a solution said to be diluted, concentrated or saturated?
Amount of solute dissolved in it.
Yeah, yeah, on whether some amount of solute can be further dissolved or not at that temperature. Okay, then write the name of any two substances that sublime. Yes, give the names of any two substances that sublime.
So naphthalene balls,
Which one? Naphthalene balls. Okay, naphthalene balls and
camphor.
Dry ice.
So camphor.
yeah, naphthalene balls and camphor. Very good.
The dry ice.
The dry ice. Very good. So dry ice, naphthalene balls and camphor. Then mention any one use of crystallization method. Any one use of crystallization method.
So it's used to separate.
See, a very important thing is that crystallization method, it is used to uh, separate the pure substance from impure substances. It is used to separate the
The purest
pure
form
crystals
we can
from,
obtain a purest form of the substance.
yeah, we can obtain the pure form of a substance. That is why we use crystallization method to purify the substance. Then see, why is crystallization considered a better technique than evaporation? Yes, why do we consider crystallization as a better technique than evaporation? Yes, see, during the process of crystallization, only the pure substances are separated out, whereas during the process of evaporation, other materials, or it is only the water that can be evaporated out, whereas other solid substances, which can be the impurities, they will still remain there. Okay, so by the evaporation process, suppose if you have a mixture of a little bit of sand and sugar, so if even if you dissolve sugar in water, so there will be little amount of sand left out even after evaporation. Then what is the heterogeneous? Name a substance which dissolves in carbon disulfide. So which substance dissolves in carbon disulfide? Rian?
Yes.
Yes. Is there any substance which dissolves in carbon disulfide? Okay, see, the concept here is, the concept that is used here is whether the substance is polar or non-polar. Okay, you have to remember that like dissolves like. This is the concept. Like dissolves like, that means the substances which are similar in nature. Like polar substances will dissolve only the polar compounds. So polar substances will be dissolved in polar compounds, whereas non-polar substances will be dissolved in non-polar compounds. So carbon disulfide or CH2, it is a non-polar compound. It cannot dissolve a polar compounds like water cannot be dissolved here. But yes, CH2 or carbon disulfide, it can be dissolved. Carbon disulfide can be dissolved by adding, or it can dissolve non-polar gases. Like it can dissolve a carbon tetrachloride, carbon dioxide, CH2, it can dissolve carbon dioxide, carbon tetrachloride, CCl4. Okay. It can be dissolved with each other. Okay, let's see the next question. Okay, name the apparatus used for separating a mixture of immiscible liquids. So what is the name of the apparatus? Okay, you can think of that. Let's start with this first one. All of you try to solve this question number 1. The concentration of a salt solution. The concentration of a salt solution in terms of mass by mass percentage is 20%. And the mass of the solution is 550 grams. Determine the mass of solvent present in the solution. So yeah, who is able to obtain the answer for this? How we will solve this? Jitendra? Harshit, are you able to solve the concentration
Sir,
of
I'm
salt
still
solution?
solving.
Okay. So write down the formula for the concentration. Okay, I obtained a few answers. Some people have sent the answers, it seems. Concentration is given as mass of solute. Mass of solute over mass of solution. Mass of solution multiply 100. So the concentration is given as 20%. It is equal to mass of solute, let it be M, and mass of solution is given as 550. Okay. Times 100. So see, to transpose 100, you get 20 over 100 equals to M by 550. Now 0 and 0 cancel. You can transpose 50 to the other side. You get mass equals to 2 times of 550 divided by 10. So 0 and 0 still cancel and you get answer as 110. Yeah. So the mass of solute here is 110 gram. Understood, everyone? Okay, see. Okay, for this one, again, this is a very interesting question. Question number 3. Pranav, you can speak anytime. Okay, don't ask for permission. Sharwan has given the answer. Harshit gave the answer. Very good. Okay, see. Now, answer this. Third, question number 3. Write the two components of a colloidal solution. So, what is the name given to the components of colloidal solution? If anyone remembers the components of the colloidal solution. Okay, Sampath.
The dispersing medium and dispersed phase.
Yes, they are called as the dispersed phase and dispersing medium. So dispersed phase is the solute and dispersing medium is the solution, a solvent. So dispersing medium is the solvent and dispersed phase is the solute. Then smoke and fog are aerosols. Smoke and fog are aerosols. How do they differ from each other? So first of all, here you will explain what are aerosols. First you will explain what are aerosols, then how do they differ from each other. Okay, Sampath is ready with the answer. Sampath, I can't see anyone else has hands up. No one else has raised hands. Yukta? Yukta?
Yes, sir.
Okay, can you give the difference? What first of all tell what are aerosols?
Sir, aerosols, are they like the mixtures of the solid that are like suspended in gas or something?
Aerosols means a solution of solid and gas. So fog and smoke both are aerosols. Both are made up of a solution of solid and gas. What is the difference between them? The difference between them? See, the difference is that the smoke and fog, the density of smoke is less, whereas the density of fog is higher. Okay. The smoke is very dangerous. In the smoke, it may even lead to death, but the fog is not dangerous with it. It doesn't cause suffocation problems. Now see, try this question number 6. Try out question number 6. You have a solution of acetone contains 30 ml of acetone in 570 ml of water. Calculate the percentage concentration of the solute in the solution. So what is the percentage concentration here?
5%.
5%, right? It's 5%. 30 divided by 600 mass of solute, that is 30, divided by mass of solution, that or volume of solution, that's 570 plus 30, and multiply 100. So you get 30 over 600 multiply 100. So the two zeros, they cancel each other. You have your 3, that's 10, and 2. So you have 10 over 2, that's 5%. Okay, let's try this question number 15. Just after the question number 15, we will end up. So all of you be active, try to answer this question. If everyone answers this correctly, I will just, then we can finish up quickly. Solubility of potassium nitrate at 313 Kelvin is 62 gram. Okay, anyone got the answer? See, solubility of potassium nitrate at 313 Kelvin is 62 grams. Okay, so when we say its solubility is 62 grams, that means it can dissolve, or 62 gram of potassium nitrate can be dissolved in 100 gram of water or 100 ml of water. What mass of potassium nitrate would be needed to produce a saturated solution in 52 gram of water? Anyone obtained this? Okay, you just try out this question. We'll see again in next class. I'm just adding this in the group or on the Wise app. Okay, try out this question number 15. Bye all of you. If you are
Thank you,
not able
sir.
to solve, we'll do it in next class.
Thank you, sir. Bye.